Hello everybody, in this new video, and in this video we're going to be looking at the basic of redox reaction, right? So what is a redox reaction, you might ask? It's basically the concept of redox reaction, those reaction in which both oxidation and reduction takes place simultaneously is called redox reaction. Now you might be confused, oh, what is oxidation, what is reduction, what am I writing in this, oxidant or reductant? Well, we're going to be looking at them in this particular video, right? In this video we're only going to be looking at the classical concept of redox reaction. There are two types of concept: classical, electrical concept, right? And then there's also the way of finding redox reaction in oxidation number. We're going to be looking at this in the third video, and in the second video we are going to be looking at this electrical concept and also spectator ion, right? So let's move on to the first topic, which is oxidation. Now, what is oxidation, you might ask me? Well, as you can see here, it's the addition of oxygen. It's that simple. It's literally given in the word itself, addition of oxygen. Now if the oxygen gets added, right, what part might be removed? Of course it's gonna be hydrogen. So oxidation is the addition of oxygen, removal of hydrogen. Now let me ask you guys a question. What is oxygen and what is hydrogen? Which one of them is an electronegative species? Which one of them is an electropositive species? Well, electropositive species refers to those species that lose electron. Hydrogen is a metal, group 1 element, right? So it's gonna lose electron. Of course it might also gain electron in some cases. We're not going to be looking at that. We're only going to be looking at the losing electron part in this particular situation, right? So S2 is a electropositive species. Now what is electronegative species? It's gaining the electron, right, which is done by O2. Now if you have difficulties in understanding this, you can use an example. Let's say gifts, right? It is a positive thing that you're gifting others gifts and not expecting them in return. So basically you're gifting gifts to everybody. That's a positive thing. But if you're only getting the gifts from everybody and you're not gifting them, that's a negative thing. It's the same, right? Getting the electrons, gaining the electrons from others, that's electronegative. But giving the electrons to others, that's electropositive species, right? You can understand this in that example. Next is reduction. What is reduction, you might ask me? It's the complete opposite of oxidation, right? Basically in reduction, removal of oxygen takes place, polar opposite of oxidation, and addition of hydrogen takes place, polar opposite of oxidation. Now let me give you guys a definition, right? You can write it, but you can just make your own definition if you just remember this part, right? Oxidation is basically the part of reaction which involves addition of oxygen or electronegative species, or removal of hydrogen or electropositive species. What is reduction, you might ask me? Reduction is the part of reaction which involves addition of hydrogen or electropositive species or removal of oxygen or electronegative species. Now we're going to be looking at oxidizing agent. Now what is oxidizing agent? What is reducing agent? What is oxidant? What is reductant? Well, oxidizing agent and oxidant are the same thing. Reductant and reducing agent are the same thing, right? Let me give you guys this example. CuO plus H2 results in Cu plus H2O. Now CuO undergoes removal of oxygen. That means it's getting reduced. H2O is added. Basically H2 results in H2O. That means oxygen is getting added. It's oxidization, right? Now this might be a little confusing, but CuO is actually getting reduced, right? You saw this, but it's an oxidizing agent. Why, you might ask me? CuO helps S to get oxidized. That means it's an oxidizing agent, right? And S2 helps CuO gets reduced. That means it's a reducing agent. So if you're getting oxidized, you're a reducing agent. If you're getting reduced, you're an oxidizing agent. It's that simple, right? It's the polar opposite basically, right? And then we're also going to be looking at limitation of classical concept, right? We have reached the end of this video. Now, what is limitation of classical concept? Why do we need electronic concept? Why do we need oxidation numbers? Well, as you can see in this particular line, works in atomic level only. Can't explain gain or loss of electron. Now, this particular classical concept cannot explain this kind of stuffs in electronic level, that is gain or loss of electron. It only explains redox reaction in atomic level. That's why we need the electronic concept, which explains the gain or loss of electrons in terms of oxidation and reduction. So if you're losing electron, you're getting oxidized. If you're gaining electron, you're getting reduced. How? I'm gonna be explaining that in the next video, I guess. And this is it for this video. I hope you understood it, and if you have any types of confusion, you can just type it in the comment, or of course source the AI. AI is very powerful basically. ChatGPT, if you give correct prompts to ChatGPT, you can make reading seem like you're playing a quiz or game, right? You can also search ChatGPT or write it in comments, I guess. But that's it for this particular video. Thank you for watching, and see you guys in the next video, where I'm going to be looking at the electronic concept of redox reaction. Now let me basically summarize this, all of this in one sentence. Redox reaction. What is redox reaction? Those reactions in which both oxidation and reduction takes place simultaneously, right? Oxidation cannot take place without reduction taking place. You have to understand that. Are called redox reaction, you know that. And then oxidation, reduction, I've already explained to you. Addition of oxygen is oxidation, removal of hydrogen is oxidation, removal of oxygen is reduction, and removal of addition of hydrogen is reduction, right? And that's it for the video, I guess. Thank you for watching.